Now let's use theorem 12, which stated the derivative of a to the x is natural log of that base a times a to the x power. So we are going to use this theorem to do a whole bunch of problems. Okay, so starting with the first one, y equals 2 to the x power. How would you find y prime? Well, y prime is, first write down natural log of 2, whatever that base is. Natural log of 2. If it was 5, I would have written down 5. You see what I mean? All right. And then you multiply by that original 2 to the x power, and that is it. I am done differentiating this function, y equals 2 to the x power, using theorem number 12. Okay? How about next one? Let's do this one. Y prime is equal to, what do you write down first? Write down natural log of, I'm sorry, I want to keep this consistency here, guys. I'll write down natural log of 5 in the parenthesis, and then I'll copy down 5 to the x power. If the exponent is just x, that's all you do, really. That is as simple as it gets. All right, how about one more? It's a decimal. So what? It's the same thing. Y prime is equal to, what do you write down first? Natural log of 1.4. And then you're going to multiply this by 1.4 to the x power. And those were the straightforward, easier examples, I believe, right? Just using theorem number 12. And you know what? D is an easy one too. Let's do D too. D is going to give us y prime equals, the base is 4. So let me write down natural log of 4 and a nice parenthesis. And then I'll copy down, that's getting multiplied by 4 to the x power. We are done, A through D. As you can see, some other ones are a little more confusing. Actually, E is going to be a, okay, I'll do F first. I'll do F first, okay? So if I'm taking the derivative of y, just y prime, 5 is just, it's just here, and it's supposed to be a multiplication dot. I'm sorry why it looks like a square here. Okay, 5 is just in front of it. Just leave 5 alone for a second. And then, because it's just a constant, okay? Hey, you want to be technical over here? You want to write down that y prime is equal to d dx of 5 times 3 to the x. All right, you said you wanted to be technical. Then guess what? I can pull out this 5 to the front. I'm sorry, I know you never said you want to be technical. I just wanted to use my new tools. But it's not cooperating. Oh, goodness. But if I pull out this 5, I will get 5 times d dx of 3 to the x power, right? And isn't this just like what we did on the previous problems, right? So I'm going to get 5 times natural log of what number? 3. And that's getting multiplied by 3 to the x power. I'm out of room. Let me make this a little bit smaller. That's getting multiplied by 3 to the x power. And here's the biggest mistake, though. Some students would love to simplify this even further. They want to multiply 5 times 3. They want to multiply 5 times 3. You cannot do that because that 3 is getting raised to the x power. So this is as simple as it gets. And it's a little awkward looking, but hey, this is what it is. So I will stop here. And now what I like to do is, guys, I like to keep, if it's a product, I like to draw some parentheses around each pieces so that it looks all organized, okay? So that was F. And I don't really have to write all this notation. Like, I don't have to write down all, what was all that? I don't have to write down all this. I can just pull out the 5 in my head. Like, for example, down here. I can completely ignore that 3 in front and say y prime is equal to, and 3 is just hanging out waiting for the other guys. And if I take the derivative of 2x, what's that going to be? I'll change my color. That is going to give me natural log of what number? 2. And that's getting multiplied by 2 to the x power. And that is it. So without writing all that work that I did on F, you guys can do that if you want to. Now I skipped the other ones. I'm skipping E, H, I, and J because those are the ones that I have to use a chain rule. But K and what's that? Is that L? K, L. Okay. K and L are the similar type of problem. It just got, nasty looking numbers like decimals. But, when you do the application problems, you are going to see more of these instead of like clean 2 or 5. So let's do this one. Same thing applies. I guess I can say A prime, but I will go ahead and write this as dA dt. Okay. The derivative of A with respect to t is equal to, well, that 380 is just a number, right? So you copy that 380 down. But now that is about to get multiplied by the derivative of 1.605 raised to the tth power. So what is that going to be? That is natural log of 1.605 getting multiplied by 1.605 to the tth power. And I know it's not the prettiest answer, but oh well, it is what it is. But at least I can make this a little bit smaller so that it fits in its box, right? Hold on. But that 380 doesn't really change anything. It's just still in front of it. We had to just work on the derivative of 1.605 to the tth power. And that is what this part is. Okay, let's do one more similar to this. How about this? Almost the same, isn't it? So, what is dA dt? You're hearing a little infant singing. dA dt. That is, well, 125 can wait. Agree? 125 can wait. But now we need to find the derivative of 1.56 raised to the tth power. And that is going to be natural log of the base, natural log of 1.56. And we must multiply this by, if I can write so small, I write too big. I'm about to multiply this by what? 1.56 to the tth power. And there is nothing else we can do about simplifying this. Oh, what was that? So we are done with this problem. So we saw, these numbers were just not the prettiest, like 1.56 or what was the other one? 1.605. But they were the similar type as F, and this one is, they were similar as this one and that one, right? I'm circling all these. These were the similar types. And the other ones that we did, hold on, let me use a pink color. This, and this. They were the similar types, but why did I leave all these rest of them blank? Because the other ones, you guys, we have to use the chain rule for it. So, I've been going for about 9 minutes now. I will stop this video, and then in another video, I will do E, H, I, and J. Okay?